I want you to give me your high level definition of the difference between machine vision and computer vision. Um, are we looking at the same thing? Are these two worlds melding? What are we talking about now?
Yeah, I think, you can probably find a lot of different definitions of those two um, uh, sayings or words, but basically, um, computer vision being maybe the broader category of anything that takes an image and processes it, anything from, inspecting license plates to people counters and all kinds of more generic kind of vision processing using a computer, whereas machine vision is a more specific term typically used in industrial or factory and warehouse type environments where you're actually looking at product being made or created and being processed, and therefore you're you know leveraging camera and imaging and technology to do a specific task for an operation or in a kind of more business setting rather than security control or those type of applications.
Mhm. I wonder if you can help us demystify some of the expectations about machine vision as well. For example, what can you do today that you couldn't do in the past, and what can we not do yet that people think we can achieve?
Yeah, yeah. I mean, fundamentally, we see the world, as people through our eyes and brain, and we are, a vision processor ourselves, and we're an amazing machine vision system as people. It helps to walk through the world, to guide us, to motion, et cetera, as well as to see, parts and be able to inspect. And traditionally, machine vision has been applied to very much kind of deterministic objects, things that are easily defined as good or bad, defined as specific, square measurements, et cetera, and less subtlety of, of kind of comparing images and whatnot. With advances in deep learning and AI, machine vision technology and machine vision capabilities come closer to how a human interprets the world, but still, we don't have the capabilities today in the hardware, in the software, and the algorithms that are at the same level as a person. So it's closer than it's ever been, but it's still, significantly less. A person can perceive a defect or a scratch or a misalignment of something typically much better than a machine vision system can. Of course, the exceptions are when things are very, very small or very high speed. You can think of, like, we can't see semiconductor parts unless they're under a microscope, or we wouldn't be able to see, bottles whizzing by on a packaging line unless somebody, stop motion or something, right? But machine vision systems can do that. So historically, machine vision systems were used in applications that were either very fixed and very much kind of artificial parts, non-organic type applications, or applications where humans weren't capable because of high speed, high resolution, and things like that. Now with AI and deep learning, there are more and more applications where humans and human inspection could be realistically replaced with machine vision tools, advanced tools like anomaly detection or segmentation analysis, telling one part from another and saying, okay, this is a part A, this is a part B, based on subtle features, can be trained into an AI model and can be effectively used with those type of tools, where traditionally it would be very challenging to use kind of traditional algorithms to create that type of segmentation or anomaly detection type applications.
I wonder if you can give me or walk me through an actual application where you're actually using that methodology. What are you excited about? Tell me about at least one application where you've been able to move the needle, so to speak.
Yeah, I think, there's some simple applications. I think we might have shown it at that trade show that we were at, where um, there are a lot of assemblies in the world where one, cable or one electronic is plugged into another. And these could be done by people or they could be done by a machine. If you open up your cell phone, for example, there's a lot of little connectors that are seated into other parts and the lens and the camera system is plugged into the main board and the display is plugged in and the seating of that two pieces together is critical that they're plugged in and maintain that connection over time. And traditional machine vision, you can kind of look at the gap and try to measure it and use lens and lighting, but it has historically been a challenging application because where do you set the threshold or what's good enough as far as how seated is a connector, for example? What we were showing at the show and what some of the applications we've been able to do are some of the subtleties of that threshold of what's good enough and what's going to maintain. So if you have a data set or a set of images that you train a AI model around, and you can show all the different nuances of connector seated and not seated, then you can set a different way of inspecting it, such that, if you get feedback from the field where, it wasn't quite seated enough, or there's some way that the connector slightly unplugged, but then eventually it becomes unplugged, you can feed that back to the original algorithm and say, okay, that slightly unplugged is an unacceptable part and put it in the reject of the AI. So there's opportunities like that it creates where kind of your typical more deterministic algorithms become very complex and very difficult to program, and AI and deep learning and kind of using that anomaly detection type algorithm or classification algorithm makes it easier.